You pull a sad container of leftovers from the fridge, press one button, and ask a plastic box to make yesterday's rice less depressing. The box hums. The plate turns like it is on a tiny stage. 90 seconds later, one corner is lava, one corner is still winter, and somehow this is considered normal. The weird part is not that the machine is imperfect. The weird part is that it exists in your kitchen at all. A microwave oven is basically a domesticated piece of radar-era hardware. Its family tree runs through wartime electronics, military detection systems, and an engineer who, according to the famous company story, noticed that a candy bar in his pocket had melted while he was working near radar equipment. That is the famous origin image: one pocket, one snack, one suspiciously warm discovery. But the real story is better than a single lucky accident. The candy bar did not invent the microwave oven by itself. It pointed at a question nobody had been asking loudly enough. If a machine can send out invisible waves powerful enough to help find aircraft, what else can those waves do? Humanity looked at a radar component and eventually said, yes, but could it make soup angry? A workshop at Raytheon in Massachusetts during the Second World War is a strange place to begin a kitchen story. But that is where Percy Spencer enters. In 1945, Spencer was working for Raytheon, a company deeply involved in radar technology. He was not a university-trained celebrity scientist. He had grown up poor in Maine, left school young, taught himself electrical engineering, and became the kind of practical inventor companies depend on because he could make difficult machines behave. The machine at the center of this story was the magnetron. A magnetron produces microwave radiation, and wartime radar systems used that radiation to send out signals and detect objects at a distance. During the war, better radar meant better warning, better navigation, and better chances of spotting aircraft or ships before they spotted you. So Spencer was not standing in a kitchen trying to improve lunch. He was around industrial electronics built for a military problem. That matters because the microwave oven was not born from a chef asking for faster potatoes. It was born from the leftovers of an arms race in detection technology. A soft candy bar in a pocket is the part everyone remembers because it is perfect invention story material. According to Raytheon's famous version, Spencer was near an active magnetron when he noticed that candy in his pocket had softened or melted. Later tellings argue over the exact snack, sometimes calling it chocolate, sometimes a peanut cluster bar, which is how you know history has entered the snack aisle. But that moment should be handled carefully. We do not need to imagine a sacred museum candy bar with a tiny velvet rope around it. The safer version is this. Raytheon's company history story says Spencer noticed the heating effect because of melted candy. The exact snack and exact second are less solid than what happened next. Spencer investigated. Instead of shrugging and buying a less vulnerable snack, he reportedly placed popcorn kernels near the magnetron. They popped. That was a much clearer signal than pocket candy, because popcorn is basically nature's tiny pressure gauge. If invisible waves can make kernels burst open, something real is happening. The next famous test, depending on the version, involved an egg. The egg exploded. This is both scientifically useful and emotionally predictable, because eggs contain water, pressure builds, and laboratories seem to attract one bad idea in a shell. Those tests pointed toward the basic cooking principle. Microwaves are a form of electromagnetic radiation. In a microwave oven, they interact strongly with polar molecules, especially water molecules, making them rotate and jostle. That motion becomes heat. The oven does not cook food with a mysterious radioactive curse. It uses invisible energy to make parts of the food wiggle until dinner happens. This is also why microwave heating can be uneven. Food is not a perfect block of identical water. A potato absorbs and moves heat differently than soup. A frozen burrito may have an outside that is ready for battle, and a center that still remembers the freezer. The spinning plate is not there for elegance. It is there because movement helps reduce hot and cold spots. A patent page is less charming than an exploding egg, but historically it matters more. Raytheon understood that Spencer had not just found a party trick. The company filed patent applications related to treating food with high-frequency electromagnetic energy in the mid-1940s, with a major Spencer-associated United States patent filed in 1945 and issued in 1950. That paper trail is where the candy story turns into a technology program. Raytheon then gave the machine a name that sounds like it should be guarding a moon base: the Radarange. Introduced commercially in 1947, it was one of the first microwave ovens sold for real use. And it was not a cute countertop cube waiting to reheat noodles in a dorm room. Early Radarange machines were closer to industrial equipment than kitchen appliances. Many accounts describe them as around 6 feet tall, extremely heavy, water-cooled, and expensive enough that a normal family would not buy one unless the family also owned a small power plant and made unusual financial choices. They were aimed at places like restaurants and ships, where speed could justify a huge machine that cooked with invisible radar leftovers. The dream was not cozy home convenience yet. The dream was volume, speed, and novelty. A 6-foot metal cabinet with a defense industry name is not automatically welcome next to the sink. The problem was that cooking is not only a technical act. People had to trust the machine, afford it, and find counter space for it. That is a lot to ask from a humming cabinet that sounds like it has classified documents inside. Early microwave machines could heat quickly, but they did not brown food in the familiar way. A steak could become hot without getting the crust people expected. Bread could turn rubbery. Some foods worked well, and some foods became evidence. For restaurants or institutions, speed could outweigh weirdness. For households, weirdness came with a large bill. A kitchen appliance has to fit into a kitchen, not merely into a loading dock. It has to be safe enough, simple enough, and cheap enough that ordinary people stop seeing it as a machine and start seeing it as furniture that makes snacks. That transformation took decades. Raytheon bought the appliance maker Amana in 1965, which gave the radar company a stronger path into domestic kitchens. Amana's countertop Radarange models in the late 1960s were smaller and more approachable than the first commercial giants, but they were still expensive enough that many families waited. A 1967 countertop Amana Radarange is the bridge between the giant radar cabinet and the microwave most people recognize. Through the 1970s, prices fell, designs improved, and the idea of fast microwave cooking became less alarming. By the late 1970s, the appliance was moving out of the pure novelty zone and into ordinary household planning. Adoption also needed a new food culture. Frozen dinners made single portions feel normal. Office kitchens made quick reheating useful. Dorm rooms turned small appliances into survival equipment. The microwave did not just enter the kitchen changed around it. Companies learned to sell reassurance. Cookbooks explained microwave timing. Manuals told people when to stir and when to let food stand. Packaging started printing microwave directions, which quietly taught shoppers that this humming box was now part of dinner. Eventually, the phrase microwave safe became a tiny domestic promise. Please do not turn this container into a bad afternoon. By the 1980s, microwave popcorn packaging turned one of the old demonstration stories into a mass ritual. The early legend has kernels popping near a radar tube. Decades later, people stood in kitchens listening for the pops to slow down, trying to stop the bag between delicious and charcoal. The popcorn button was not a genius. It was just confident, which is different. The microwave's real superpower turned out to be humble. Not perfect cuisine, not crispy artistry. Reheating coffee, softening butter, warming leftovers, and making lunch happen before a meeting. Inventions often win by doing something smaller, cheaper, and more useful than the original sales pitch. A cup of water in a microwave looks harmless, which is why the modern myths are worth sorting out. The Food and Drug Administration says microwave ovens do not make food radioactive. The machine uses non-ionizing radiation to heat food. It does not turn leftovers into a science fiction prop. It also does not cook magically from the inside out in the way people often say. Microwaves penetrate only a limited distance, and heat still moves through food by conduction. That is why United States Department of Agriculture guidance tells people to stir, rotate, and let food stand when the instructions call for it. Standing time is not decoration. It gives heat a chance to even out, and it helps avoid the thrilling experience of taking one bite of cold lasagna and one bite of molten core sample. There are real safety rules, just not the spooky ones. Metal can spark if it has the wrong shape or sits in the wrong arrangement. A fork in the wrong place can still create a small indoor lightning show. Sealed containers can burst when pressure builds. Superheated water can erupt when disturbed, which is a rude surprise from something that looked calm 3 seconds earlier. The appliance is ordinary now, but ordinary does not mean consequence-free. The deeper punchline is that the microwave became boring only after a long chain of very unboring events. A wartime radar component, a self-taught engineer at Raytheon, a melted candy anecdote, popcorn, an egg with poor prospects, a giant machine called the Radarange, years of commercial awkwardness, then slowly the affordable countertop box. So the next time your leftovers come out with one hot bite and one cold bite, you are not just experiencing bad reheating. You are touching the residue of a strange technological migration. Radar went to war, came home, shrank, joined the appliance aisle, and now lives above the stove, making oatmeal threaten to overflow. The melted candy bar story is not the whole history. It is the doorway. The real invention was turning an accidental heating effect into a product people could trust, afford, and squeeze between the toaster and the sink. The microwave oven did not begin as a kitchen dream. It began as a radar problem, became a laboratory surprise, survived being a giant, expensive cabinet, and finally earned its place by doing one deeply human job: making yesterday's food feel like a decision instead of a punishment.